from the DBE side. So
didn't actually, pick up the pieces, but
we will move on, and I just hope now that I press sound for one particular video that I want to show you, but here we go. So
your slides are not showing.
It's not showing. Not showing.
You need to upload it and share it.
I thought I did that.
No, it's not here.
Okay. Let me close that. Let me go here. Sound. Still not sharing.
We can see it now. You just need to put it in presenter mode, Mrs. Kuta.
Okay, will do. Will do. Can you see it now?
All good, Mrs. Kuta. You may go.
Okay, thank you. And I'm terribly sorry for what just happened. Like I said, I don't know, I suppose there's no excuse for what happened. But today, good afternoon to the teachers, to the HODs, to whoever's on the platform. Thanks for attending the session. We're going to endeavor to just give you the scope of the terms ATPs, what it's all about, and how to engage with the documents we have optimally to give our learners nothing but the best. And I also just want to thank the North District for being support with regards to providing the links so everybody can attend the session. Yeah. So here we go. The presentation outline will involve the curriculum, the purpose, much support for teachers, and obviously a conclusion. So what is the purpose? To highlight what is critical skills and knowledge, and how to teach via the CPA. And I'm going to implore you to keep an open mind this afternoon, teachers. Keep an open mind and just to see the possibilities. And if you don't, if you are not going to be able to remember anything, we'll get there. When I get to a point that I say to you, listen, if you can only remember, for instance, the word sabotaging and the different kinds of sabotaging we get, and why sabotaging is so important, okay, for our learners, right? And yesterday I spoke to the grade ones, and we spoke about visual perception. Okay, that skill that is so important, because if you look at the screen now, what are you doing? You're visually looking at it, and you're trying to put the sentences together and trying to make sense of it, right? So here we have, what curriculum support documents do we have for our grade 2 classroom? First and foremost, your CAPS document. I can't stress enough that this is so important, because it gives you everything you need to know, okay? And your DBE workbooks. And again, I can't stress enough the section C in the CAPS document that teaches you how to actually teach. That just unpacks your content and your knowledge and your methodology for you. Also remember, mathematics is a skill, and all skills need to be practiced, okay, in order to master it. Thinking of learning to drive a car. Learning to drive a car is a skill. And the same, by the way, with reading. And also, I'm also factoring in the fact that you are one teacher in the classroom, and you are responsible for teaching a lot of subjects, right? 4 to 5 subjects you're teaching in that classroom. So first and foremost, reading is key to enable learning in all other subjects, and especially at the grade 2 level, right? So you know what emphasis and how much you invest in teaching your children how to read, because that is going to determine also whether they can do the mathematics. So let's go on to what the curriculum overview is all about. And here I just broke down what your CAPS document involves and how it can support you. Okay, look at the grade 2 section. So if we take it apart and if we look at the grade 2 overview and the grade 2 here, the clarification notes, we'll see a much thinner document. The document might look voluminous and it might be intimidating, but don't let that scare you. It has a lot of information for you. Okay, so what is my classroom management plan all about? This is what my classroom management plan is all about. This is a suggested idea in the ATPs and it's also in your policy document, right? So why do we talk about teaching in ability groups? It just has so much merit, right? We target lessons at the right level. We allow for individual attention. We can just pace ourselves as teachers. We can connect with our learners in smaller groups. The other learners, while they're busy at their tables, they're doing passive listening. So they're also engaging and they're also learning in that way, right? And when we sit on the carpet and we engage with our group of about 12 to 15 learners, we're building confidence and we're getting to know our learners better. And we also teaching values and attitudes. How? By the way we engaging with them and the way we interact and the way they interact with their peers on the carpet, right? They're learning valuable values and attitudes and just sharing and caring. That's very, very important. So when we look at our overview, our grade overview, in particular, because I want you to have a look at all the boxes I've put in here that runs across. So this is basically numbers, operations, and relationships for the entire year. For the entire year, okay? And we're going to look, particularly, we're going to look at solving problems in context and explaining solutions to problems. How do we go about doing that? Right? How do we go about doing that? And when we look at, and we're also looking at adding the same number, that leads to repeated addition, and it in the end leads to multiplication. Also have major problems with that, and we look at our major problems and we see our gaps in our diagnostic assessment and also in our and we're looking at the diagnostic that we do the error analysis and our baseline assessment. So by now, some of you probably completed the baseline assessment already, or you just about started it, so you can see what your gaps are. And I said yesterday on the platform, do not be dismayed, do not be perturbed if your baseline is poorly attempted or poorly done, as long as you in your heart of hearts know that you have not taught to the task. You gave that baseline pure and as clean as possible. You didn't attempt to revise any of the work that's in the baseline, because obviously you had read through the baseline before you share the items with your learners, right? The aim is for you to see what your learners know at this particular stage, so it can inform your teaching and your planning. I can't stress that enough. So it can inform your teaching and your planning. So what do we do in the foundation phase? What teaching approach do we use? We use the famous American psychologist Jerome Bruner's CPA approach, right? Where we talk about the concrete, which is the hands-on use of visual apparatus. There we have our 15 blocks, and here we have our 15 cubes. All the concrete, and we're making links. We make links for our learners in the classroom until they are eloquent enough to make their own links. And then you know, wow, my teaching is resonating, they are learning, right? But for starters, you can certainly show them, linking it with 5-rand coins as well. And we also know that our learners are poor at doing the working with money. How much change we get, they can't work out that. So even us as adults, sometimes we battle. We go to the shop with 100 rand and we buy that loaf of bread for 28 rand, and we check our change quickly and we work backwards, right? So that's the mental picture that we have in our heads. So how do we get our learners to be able to do that? You see all the links, the 3 hands as well with the 5, 10, 15 fingers. Then we go on to the pictorial, the picture and the diagram stage, right? So every concept is taught via the CPA. Every concept must get its deserved attention with regards to the CPA approach. Then eventually we do the abstract. There we go. It's also called scaffold learning if we look at the bigger scope of things, as it builds on prior knowledge. So we'll build on what they did concretely, we'll build in a pictorial way, and then we will eventually conclude with the abstract. Each stage builds on one another, and through the 3 stages, learners master new concepts via physical objects, pictorial representations, and like we all tend to want to run to from the onset, the abstract methods, the numbers. But we need to look at it and see the big picture and see what learners require. Now, this is a problem in the grade 2 workbook. Lisa has 9 counters and Akka has 8. What is the total? And the little box provided there, we can put in the total, right? So some of us want the learners to write just the numbers, some impress and imprint that learners must write down the total number, and they want to see the word counters, different strokes. But if the learner writes down 17 because the answer is 17, he must get a correct mark, because we are assessing the skill here, okay? We are assessing the mathematics. And if the child knows and can work out that 9 plus 8 is equal to 17, then the child must be credited accordingly. I can't stress that enough. The other little do's and don'ts will come into what to do what. To enhance reading in the classroom, to enhance correct sentence writing, fine. Give them time and let them practice. If you can show me that you have given opportunity to practice, fine. But if the child has mastered the skill, the mathematics skill within this word problem, we are going to have to give the child the credit, okay? If the child just writes 17, you cannot mark it wrong. Then you need to re-look at yourself, okay? And you need to ask, what is the maths here? Did the child know the maths or did the child not know the maths? Enough said for that, because I get a lot of questions relating to that. So mastery comes through opportunity and varied practice activities. I can't stress that enough. I always say repetition leads to the practice. We do the repetition. And I like to say incessant repetition helps to consolidate knowledge and to build confidence within our learners. I'm going to just show again concrete the bottle tops. The 9 and the 8 bottle tops, different apparatus we use, the Dean's blocks there, or the place value block, some of us call it. Then from there we move on to the pictorial. I want to do the scene stage where we actually look at the representation there, different representations. Very, very important. We must give learners the opportunity to experience all of it. Okay? And there's the abstract. So, in grade 2, it is expected that learners can read, understand, plan, do, and check the word problem. Counting levels show us their thinking ability. And throughout, I'm going to talk about the counting levels. And if we just look at this picture here, I've got to factor in everything now because let me just show you quickly. If you look at this picture here, and if you look at this 8 counters here, are the learners able to see instantly that it's 8? Are they able to see instantly that it's 9? Can they do the sabotaging here? Or do they see, what do they see in their minds? Do they see 3, 6, 9? What are you seeing currently? Are you seeing 3, 6, 9, 3 multiplied by 3, 3 plus 3 plus 3? Are you seeing 2 groups of 4? Are you seeing 4 groups of 2? Are you seeing 4 plus 4? Are you seeing 2 plus 2 plus 2 plus 2? What is your perceptual skill here entitling you to be able to see? So think of it, what our learners have to take in their minds, in their heads, how they need to picture this, okay? And therefore I wrote here that the counting levels will show their thinking ability. So constantly teachers need to do that formative assessment. How did you get there? What was your thinking? you need to establish what learners are thinking about and how their thinking process is happening so that you can give credit, so that you know how to plan for your next group or for the next day for the same group. Okay, who got it? Who's at the pictorial stage, or who's at the abstract stage, or who is not? Who must still stay with the concrete stage? Right? Has mastery happened? We're also going to we're looking at the problem solving in context. We're also going to look at repeated addition leading to multiplication. Repeated addition leading to multiplication, because some of us don't have a neat grasp of what repeated addition is. Repeated addition is addition of the same number over and over. So there's an example of pictures, the concrete, the hats, and then the little concrete representation, pictorial pictures there, representation there, and then we have the abstract. 3 groups of 2. 2 plus 2 is equal to 6, and 3 multiplied by 2 is equal to 6. And we also look at the half a dozen of eggs, and we look at the different arrays that it affords us. Here we can see, if we run it this way, we have, if we hold the box exactly as it is, we have 2 multiplied by 3. If we turn it around, we'll have 3 multiplied by 2. Okay? And that's why I put the whole the abstract number sentences. I put the number sentences here so that one can see. And we also need to remember that our children are coming from grade 1. They come with knowledge. They come with a lot of skills. So we need to build on that strengths, right? That is why that baseline assessment is so crucial, because it will inform what your learners can do, what your learners can't do, so that it will in turn inform your teaching and your planning. Your planning and your teaching that way first. Because remember, teachers, if we fail to plan, we are planning to fail. We're planning to fail dismally. Right, so here we have an example from the workbook. I love to use these pictures because it just gives us multiples of 2, multiples of 3, multiples of 5, etc. Right, so we're building on learner strengths. What do they know? We look at this picture, we're looking at 3. I circled here the 3 girls on top, and we're looking to see how we can stretch this so that we can busy ourselves with this one picture for the entire week. Teachers, for the entire week. We need to work collaborative, put our heads together in the classroom so that we can, at school, in our PLC, so that we can support one another in extended. Let me just go back here quickly. I want to look at this picture here. And if you look at Lisa has 9 counters and Akka has 8 counters, right? I want you to think about using that same number, because here is a very important strategy and skill that comes into play here, where they need to breach the 10, where they need to fill the 10. So if you take this one example and you put it on your chalkboard, and every day, for the week, you do the same sum. Every day, you just change the numbers. And you work with number 9, showing them how to breach. And then next week, you can do 8. You use the very same problem. You just change the numbers. And you can do the counters, if you want to highlight the counters. Or if you expect learners at this stage, they should be able to hold that counters in their minds and have that visual picture. Okay, so think about it. Think about the practice you will afford, the much repetition that will support your teaching and their learning. Okay. Right, here we go. So we're looking at concrete, pictorial, and abstract, because that's what the endeavor is. And here I have the three girls, and we're going to look at how many eyes. Pictorial picture. How many? Another way in doing it in the frame, the 5 frame, and here we have the abstract. So look at that one picture and look at how we can work according to the concrete, the pictorial, and the abstract stage. Okay? Let's look at the 5 now. Let's look at the 3 now. So what are we doing? What are we building on? We're building on counting in multiples, we're building on repeated addition and multiplication. That's quite a mouthful, that's quite a lot. And that cannot be done in one day. It cannot be done in one day. Hence me saying, think about this picture, think about how you can stretch this picture for the entire week. But no, we want to give this picture to the learners and we want to say, listen, do this for one day. We use it as a keep busy activity. Today, I'm appealing to you to keep an open mind and to see the potential of what the workbook, the colorful pictures has to offer. Okay? Because I can take this picture and I can even say double 3. And then I can go the same route. Do it concretely with the eyes, do it concretely with the 5, the patches, and do it concretely with the 3. And take it to the pictorial level as well, and the abstract. I'm talking about doubling up. So we will have 6 here. 6 sets of eyes. Okay? Think about it. How we can enhance the teaching and the learning in the classroom. Because the aim is for us to provide varied practice opportunity all the time. Set the 3 girls, here we're looking at 2. I'm just stretching what I just mentioned to you now, okay? So the entire week we can work with this because we're going to ask them to draw and to, let me just go back here, okay? Looking at the 2 here, to the eyes, the drawings here, and the abstract. Can they do it this way? So the very first one we did, and the practice run should indicate to you if you work in the class, when they do the first page here, and you do your formative assessment, you can gauge whether you can move with your learners in this fashion or not, or whether you need to stand still and reteach. So we go to the workbook and we look for more examples. And we get to this picture here of, here we have the 4 girls again. But we also look at more ideas. And I went here to where we have the sweets. And then there's a lovely word problem here. How did you count the sweets? Now, some children will say we counted in 1, some will say we counted in 2, some will say we counted in 4s, etc. So here we have this lot counted in 4s, this lot counted in 2s, in 3s, this lot counted in 2s. Well, now I'm getting a bit confused here. Sorry about that. The question is, how did you count the sweets? And they can decide, okay? In the classroom, you'll have your counters, right? So have a look at what other ideas you can find in the DB workbook to count. There's your multiples of 5. Here's your bicycles that give you the multiples of 2. Here's your tricycles that give you the multiples of 3. Here's the sweets that give you the multiples of 2, okay? So with each one here, we have a number sentence. With each one, we have a number sentence. There we have the 3-pot stands as well. And that's how we draw links for our learners. Where else in your environment do you have 2 plus 2 plus 2 plus 2? Where else in the environment do we have 3 plus 3 plus 3? Do we see 3s happening? Do we see 4s happening? Do we see 5s happening? Okay? And don't forget, bring in the money as well, so that we can work with our learners, because we know that is an Achilles heel. They cannot work with money. They cannot decipher how much change And counting the 2 round coins is brilliant for them to count in twos. When we do counting in twos, and we linking it to the counting chart. Counting the 5 rand coins is brilliant for them as well. And you have that play money in your classroom. If you don't have, you can make copies of that, mount it on cardboard, laminate it, and cut it out so that you have play money for that particular purpose. To show links, right? To show the links. There we have draw 8 groups of 2, draw 10 groups of 2, draw 9 groups of 2, and extension of the 7 groups. You'll find this in your workbook as well. But this is just to show you how you can extend it further. So just imagine taking this one example here, putting it on the board. 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, 7 groups of 2. You do on one day as an example. And the next day, you can extend it. You can do 8 groups of 2. The next day, 9 groups of 2. The next day, 10 groups of 2. You can work back 6 groups of 2, 5 groups of 2, depending on the level of your learners. But what I'm saying is, the practice is absolutely important. One example here is not going to crack the code. It's not going to help them to embed this. Remember, the emphasis is on consolidate. Okay? So where else in the environment can we get our groups, right? So what am I saying? What are we saying? We're saying that the CPA approach helps learners to develop confidence and security when working with abstract presentations. So how do we go about developing the concept? And I'm looking at the concept of 9. Okay? I'm looking at the concept of 9 because there is a struggle. We are battling, we are assessing. Have our learners come to grade 2? How grounded are they in their bonds up to 9, up to 10? That was supposed to be the exit skill of grade 1. How well do they know their number bonds? How well do they know 9? Has all the links been made for them with regards to number identity?
Ms. Gutham, we can't hear you. Ms. Gutham? Ms. Gutham, I can hear you now. You can carry on.
Okay. All right. So we're looking at 9 in particular. We're looking at number identification. We go to the number line. We try and identify 9 on the number line. You have a counting chart in your classroom. You ask learners to put the transparent counter or to put just a counter on 9. And you go around and you see whether they can identify 9, whether they know 9. 9 is between what number, 9 comes after what number, etc. Right? There are 9 stars. Can they identify the 9 stars? Where else in your classroom, or when you show little cards with 9 objects, can they identify 9? Number quantification, can we number objects from 1 to 9? There's an example of it, and that's how this puzzle fits together. Can we sabotage? Do we have that mental picture of 9 in our minds? We spoke about sabotaging earlier, right? Do we know what's more and less? Because if they do not know what's more and less here with regards to one-to-one correspondence, they will never be able to do the addition and the subtraction. Okay? And know big numbers and small numbers, and know what's more than 35 and what's less than 35. If we compare 20 and 10, what's more and what's less? How do we know that? That's the type of questioning techniques that we need to ask our learners so that we can gauge whether they have the grasp of it or not. All right? Whether they know more and less. Not only first they work with objects, later they graduate to working with numbers in that context. So that's very, very important. So coherence, we talk about structure and the mathematical fluency that we're looking for ultimately. Okay? That comes into play. So we're going to look at addition in particular here, and we're going to look at Nelly collected 9 bottle tops and Sipho collected 4 bottle tops. How many did they collect altogether? Some learners are bright sparks, they'll tell you straight, they collected 13. Some need to work it out, they need to fill the 10. How do we go about teaching this if our learners can't relate to this? So here we have, again, in our document here, in our ATPs, and it's also in the CAPS document, we're solving problems in context and we explain solutions to problems. We need to get that interaction with learners because we need to hear from them what they know and what they don't know. Otherwise, we're missing the plot, teachers. We're missing the plot. So they need to tell us exactly how and what they did. So even with that one sum I spoke to you earlier about the 8 plus 7, 9 plus 7, or was it 8 plus 9, 9 plus 8? Here we go, 17. Get the learner to engage the learner. Get the learner to tell you how they got to the answer, 17. That's important. Then we know there's thinking, and they've mastered that math skill. They can do 9 plus 8. Okay? And that's part of your formative assessment, because as a teacher, we are vigilant. We are constantly observing our learners. We do not want the scenario where teachers have at the end of the term, they want to do a big task out of 100 and subject that learner to doing that task out of 100, where they're scoping like 10 of the same sums, of the same items. You know, what's the purpose there? Those items are being, and that skills are being assessed throughout the term. Throughout the term, that's where your formative assessment comes in. Okay? I'm still looking for someone to give me 3 good reasons why learners must do a task at the end of the year. And if you think you know why you have 3 good reasons, you put it in the chat and tell me why your learners are doing a task out of 100 at the end of the term. I need to know 3 good reasons. Maybe I can wrap my head around it and say, okay, you're making sense. But I don't think so, eh? Doing formative assessment, and not if we are regularly engaging with our learners. Right. So how do we go about this in the pictorial way? How do we do? What is the math talk? So Nelly is saying, I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm counting. I've got the 9, and I'm counting 1, 2, 3, and I'm counting on the 9, and I'm counting 9 and 10, 11, 12, 13. That's Nelly's thing. Nelly's saying, I counted 1 to 9, and I'm going on, I'm counting on, I'm saying 10, 11, 12, 13. That's the 4, that's the 4 there, that she's adding on. Sammy's saying the answer is more than 10. I'm thinking about it. I'll get there. Sipo is saying, I will change the number combination to 10 plus some more. You see, everybody's got a different theory, which is brilliant. How do you as a teacher know? By engaging them, or by just checking how they, asking them to put it down on paper to draw their understanding. Then you can also see, right? Quickly at a glance. You're on a trajectory or you're not on a trajectory. On a winning pathway or you're not on a winning pathway. So this is what we hold up. This is what we have. 9 plus 4. And I said that is why we probably need to teach addition and subtraction of 3 numbers as prior knowledge here. So look at that. So it's 9 plus 1 plus 3 is equal to 13. So what kind of practice opportunity are we giving learners when I talk about teaching addition and subtraction of 3-digit numbers here? So the whole idea is here to show the bridging the 10, to show filling the 9. So before filling the 9, did we do filling, or we first doing filling the 9, then we're doing filling the 8, then we're doing filling the 7. Number bonds are key here because they need to rely on that number bond knowledge in order to fill that 10. Okay? Also, what is key? How many practice runs did you have with regards to adding three numbers? Did you do 9? Did you do 8 plus 2 plus 3? Did you do 8 plus 2 plus 5? Did you do 8 plus 2 plus 7? Did you do 8 plus 2 plus 1? Did you give them the opportunity to make the 10 and then to add on the extra bit? Every time you see we fill in the 10. Did they do 9 plus 1 plus 3? Did they do 9 plus 1 plus 4? 9 plus 1 plus 2? 9 plus 1 plus 7? Did they? What type of practice did they get? Okay, in order for them to display this here and noting that, okay, because he says the answer is more than 10. Here this one says, Sipho says, I'm going to have to make 10 first. Okay, and then some more, then I'll add some more. All on the right track. Nelly, in her head, she said 9 and she's adding on. So she's on the counting on stage. Brilliant. Where they all should be at this moment in time. But when it gets to bigger numbers, it becomes too easy for them. So what do they do? What do they do? Here we have making connections. Here we have, this can also be done on the number line. It's just the top scale this way. And now we did the concrete and the pictorial. And here we come into the abstract. So in some provinces, teachers use the graph paper, or I almost want to say the ledger books with the blocks. Why? Because it channels the writing in the particular columns, which is quite neat. That's why I put it up here to cater for everybody so you can see. Just my lines are a bit out here, but the end result is 9 plus 4 is equal to 13. But you can see how we build that 10 to give us the 10, the 3, and the 1. Okay? And eventually also supports the learners when they do their handwriting to just keep it neat and tidy. So there we have 10 and 3. And that's our teaching that comes in there. So, consolidating. 4 is decomposed to change 4 plus 4 into 10 plus 3. We're adding 1 to 9 to make 10. That's our 3-digit sum there. 9 plus 1 plus 3 is equal to 13. And there we have 10 plus 3 eventually that we get into. So, can we give them more practice? That is key. Can we give them more practice to support this and to embed this concept? Making a 10, adding on, bridging the 10. Repetition is the mother of all learning. I can't say that enough. Okay? So, that's the addition. Can you as a teacher now think how you can do this kind of sum to afford them the practice every single day? Okay? Every single day, build it in. Build it in perhaps for that word problem we showed you earlier, with the same word problem here. There's another variation for you. Okay? Just to see whether they can decompose, break down the number, fill the 10, add on to 10. So, 10 being a friendly number, how well do they know their 10 plus sums? When they're finished with this work, once they've completed their exercise for the day, they can take their busy book or their class book, and you can say, if they're looking for an extended activity, fold your page into 4 columns, and they can work on 10 plus sum. Then they can do, in one column, they can do 10 plus 1 right down to 9 plus 10, or to 10 plus 10, then they get to 20. In the next column, they can do the subtraction. In the next column, they can do first before they do the subtraction, they can do the how many sum, the open sentence sum, then they do the subtraction of the 10 plus, and then they can do the reverse, that is equal to. Another concept that doesn't rest well, they cannot make the sides equal. Yet they can do, this is simply making the sides equal as well. This is making the sides equal, the left side and the right side. But when we give them a particular activity in the diagnostic or in the baseline assessment, and we say, make the sides equal. And we have, for instance, 2 plus 2 plus 2 plus how many is equal to 4 multiplied by 2, making the sides equal. There's a battle with regards to what must come in either side, on the left side. Okay? So think about it, and in the DBE workbook, there's brilliant examples that even show you the scales, where they do this, making the scales equal, with numbers and with apparatus, with the balls in the scale pockets. So go to your DBE workbook and have a look at that. Okay? Let's go to our subtraction. There are 13 bottle tops. And Sipo says, I took 9 bottle tops. Here we have the concrete. 13 bottle tops. Sipo took 9. How many bottle tops are left? Again, they just give me and they just say 4, teacher. I'm giving credit where credit is due. I'm also going to ask, how did you get to your 4? Can you tell us, Sipo, how did you get to your 4? And the whole class will listen, or the whole group on the carpet will listen, and everybody's learning as well. Brilliant. So, what's the maths talk here? This one is saying 13 minus 9. We will decompose 13 into 10 plus 3. Into 10 and 3, sorry. There we go. 10 and 3. To get 13 minus 9. Have a look at the pictures here. Have a look at the graphics here. Subtract 9 from 10 and get 1. 1, 3, make 4. Have a look at what's happening here. Let me just do that. Took away the 9. So what are we left with? 1 that side and the 4. Do we see that? Let me just go back again. Using our frames, a 10 frame. You can use your Dean's blocks. You can use your place value blocks. You can use your counters, right? To show how we subtract 9 from 13. So what other practice are we giving our learners here? Because we know practice is what is required to master any skill. Same like I said earlier, I was talking about learning to drive a motor car. How do we do it? Lots of practice runs, and eventually it becomes automatic. We don't need to even think about it. So that is what must happen here with regards to bridging the 10, right? To making it 10, so that we have, and so that we can show how our learners break down the number and can do the subtraction. So calculating, decomposing 13. 13 is 10 and 3. Subtract 9 from 10 equals 1. 1 and 3 make the 4. And here we have it as well. 13 minus 9. 13 minus 9 is equal to 4. Break down the 13 into 10 and 3. If you take 9 from the extra 3, you can take it from the 10 instead. If you can't take 9 from the 3, you can take it from the 10 instead. Okay? And here we're giving them more practice. More practice. And this is the type of cards we need to give our learners so that they have very practice opportunity. Think about it. You can make it smaller so that they perhaps just do 3 a day. Each group can do 3 for the day. Or if you have your one particular sum on the board, you can just change it so that you know they're going to get that multiple practice for the whole week. But every single day of the week, you need to provide an opportunity for them to practice where they must go and fill the 10. Break down the number to make it to 10 plus, and then just do the subtraction. Very, very important. Why is it important for learners to master the fundamentals of maths? Why? I mentioned that fact that we want them to become automatic with their numbers. I know this is a big word, but I'm going to use the word, instead of saying this, just use the word automatic. Okay, we want it to be a mental thing so that they can get it in there, they can see it. Recognizing and understanding how numbers work is fundamental to all aspects. And we're saying that as learners progress through the grades, they learn about different types of numbers and how the numbers connect, relate, and link. That's very important. We want them to be fluent. We want them to be fluent and fluid. Okay? Especially, and we gauge this with the mental maths in the morning. We gauge this with the counting. How are we connecting mental maths and counting? Right? To the eventual algorithm on paper. They must see the connection. It's not separate. Your algorithm is not a separate thing. Your mental maths is not a separate thing to the counting. Your counting in multiples of 2 must link up to your repeated addition, link up to your multiplication tables eventually. Right? That's how automatically we want learners to be able to do their maths. So when I think of us as adults, how many of us know our tables pat off? 2 to 10 2 times to the 10 times table pat off, like a recitation. It's become automatic. You can pull it out of a hat. How well are our learners at that, to do that? How many of the learners at this stage know their bonds pat off? Up to 10, the number bonds up to 10. How many of them can relate to that? And can use that for other, for their problem solving, for the word sums that they eventually do. I'll skip that, but I wanted to talk about the bottle tops, the use of the bottle tops here, which I had a beautiful presentation there with regard to the bottle tops. It's about, you as a teacher, you're putting down a lot of bottle tops on the carpet or on your table, and you're asking the learners to count. Or you're doing the counting activity in the classroom, right? So now they're attempting to count. Now some learners you're asking, can you count? And tell me how many counters you see. Put about 15 there. Some learners will count and in ones. Some learners will count in twos, and they'll be left with 1, and they'll say 15 in the end. Some learners will count in 3, some will count in 5, some will say, there, I say 10, they can take 10 and they can take 5. Brilliant. So everybody is on a different level. So that is why we're doing baselines, so that we can gauge and we can group our learners according to their ability groups or according to their levels, right? To support their learning in that way. So I'm saying, how well. Now, when they're doing that links, when they're doing that counting, that is what we call, that's part of the rational counting, because now they're taking the groups and they're counting. That's the rational counting they do. Are we linking that counting to the abacus we might have in the classroom, or to the counting chart we might have? That same learner that counted in 3s, go and show us on the counting chart how you counted in 3s. Can you link your counting in 5s on the counting chart or on the abacus? They must be able to make the links, because nothing is taught in isolation. Okay? Where else do we see 3s? Think about tricycles. Think about the 3-legged pots. Okay? Think about your bicycles when you're counting 2s. Think about the pairs of socks, right? And bring in money as well. Think about your 2-rand coins. And especially in 5s, think about the 5-rand coins. Because we're having this problem.
Bonnie,
I'll get back to you, Jenny.
you have 25 minutes.
Don't tell
You
us.
have 25 minutes left. Sorry.
Sure. Okay. We're having this problem when it comes to grade 3, where our learners are still counting all. Okay? I'm going to rest it there. You know what I'm talking about. You know what I'm talking about. You know what we expect learners to be able to do. Right? I asked, do learners know their bonds? How well do they know their bonds? How well do they know their bonds? I can't ask that enough. Okay? How well? How well do they know 9? Can they fold the 10? Can we make that bundle of 10? If we know 10, we should be knowing this as well. 9 plus 1, 19 plus 1, 99 plus 1, 199 plus 1. How well do they know that? Problem solving, some more problem solving from the book. And like I said, the children don't know money. So if you have a multi-grade class, you're sitting with grade 2s and grade 3s, have a look at this quick example as to how they can work with money. The grade 2s will be working with a 50 rand, the grade 3s will be working with 100 rand. We use the same pictures. Go shopping and go buy that loaf of bread, go buy that juice, go and buy that yogurt, and tell us how much change you'll get for your 50 rand or for your 100 rand. Work at that. Okay, that was for grade thing. This was the Lego blocks, but some of you don't have the Lego blocks. I just wanted to show you that. I'll just scroll through that quickly. Counting chart. Are we showing the links? That's what I wanted to ask. Are we showing links? Are we showing multiples of 5, multiples of 3, multiples of 4? Are we showing learners the links on our own counting chart? Okay? These are the grade 2 skills that they need to know for the whole year with regards to numbers, operations, and relations. Looks a little, but it's deep. I'm asking, how deep are we teaching? Okay? Are we doing the group work? There's some more merits of group work. I always talk about number talks. I'd like us to think about doing number talks. 5 to 10 minutes, whole class activity to build number sense. Taking 20, for instance, on day 1. What can you tell me about 20? You have your chest, your card with your particular questions. 20 comes before, 20 comes after. You just have after before because you're going to use that same questions for every day. What's before, what's after, what comes between 19 and 21. 20 is how many more than 10, etc. Build up a list of questions for you that you can ask every day with regards to one number that you can hold up. Okay? Here, some more counting activities. Counting, ascending, linking it to repeated addition and repeated subtraction. Right? Facts of 4. Just to show you that the same happens with 2 and with 3 and with 5. When the multiplier increases by 1, the answer also increases by the particular multiplier by 4. Look at that. Now, here, look at this. If we had 3 here, we'd have 3, 6, 9, 12. Okay? You can see the pattern. There's our multiplication table. There's our facts of 4, of 2, of 3, of 5, of 6, of 7, etc. in that form. I'm just going to go through this quickly. Division and subtraction, there's just, according to that chart, I want to show you examples of how we can afford learners more practice runs with regards to this, making the sides equal. Not only 2 sides, look at whether is equal to sign is. We can extend it for our learners. There's our 3-digit, our 3 numbers, adding 3 numbers. More examples. Hope we're using the flashcards. And in grade 2, we concentrate on the 10s and the 1s. And there's just that bit of idea as to how you can make use of that. Here we have, again, remember I spoke about your 10 plus. There we can break down all the numbers. You have your 18 equal to 10 plus 8, 17 equals to 10 plus 7, 16 equal to 10 plus 7, 6, 15 equal to 10 plus 5, and so on for practice. So I'm just alerting you to show you that there are all these beautiful pictures that you can take apart in the workbook, and you can extend the activity for the whole week. Here we have Lynn hopped 34 times on the grass. Her brother hopped 5 times on the grass. How many times did they hop all together? Again, I'm just going to show how we use the Dean's blocks there. You can see that. Regrouping. And here I have activity to embed. And you can have an activity like this as well to embed on an activity card. You can have several activities like that to embed. Okay, and strategically look at these equal to signs, making the sides equal all the time. Regrouping. Addition mental strategies here. Here we have 34 and 20 is equal to 54. With your Dean's blocks, you can take it next to your 10 frames. Adding 10, there's always an activity at the bottom just to show, extend your learners. Extend your learners. This is 10 add 2, 10 add 6. Put your 10 frames, adding 9. And how we make the 10 there. 9 and 4, 9 plus 1 plus 3, 10 plus 3 is equal to 13. More activities, more examples. This one won't hold for long. We need to embed this knowledge in our learners. Okay, there we have the 8. Making the 10 there, fill in the 10 first to give us 10 plus 2 eventually. And here's more practice runs. So more regrouping, more with the addition, regrouping, use of the Dean's blocks, the place value blocks. You can see that Lynn scored 29 points in the game. John scored 14 points. How many points were scored altogether? And there we have the final one in your 10s and your 1s little house there, okay? In your addition house. And here, show you how we regroup. That's in a different color because that 10 went over there to make it a 10 here so that we can then do the necessary. Or that went over here to add on, right? And here we have 29 add 14. How did we get there? So why do we teach? Okay, we know why we're teaching number bonds, for learners to be able to do the sums later. There's examples of number bonds. Don't only think that it's 5 and 9. That it's it can continue to 9 is equal to 4 and 5. 9 is equal to 3 plus 3 plus 3. That's also a number bond. Okay. Here we have some more of your number bonds with regards to your unit fixed blocks, your counters, more apparatus that can be used. Okay. And it will eventually be extended for the grade 3 level. So how do we do this with the interlocking cubes? Have a look at those ideas, which is actually neat because learners put them together and they can see the different colors and they can see the addition, they can see how the cubes grow when we do the addition. Okay, so this is our problem we actually have when it comes to counting. Our learners cannot count. And they do not know that actually all that ones, that group of ones makes 110, make 110. Okay, and there's your 10, your Dean's block that shows 10, and the same can they connect it to the ranks of the what you see here in the number chart, and they see that is the 10. It's the very same 10 units that we have here. The units here that make the 10, okay, that fills that 10 for us. So that's very, very important. So where's the start of all of this? It's counting being the biggest building block in mathematics. It's counting, and we need counting to be able to do all of this. Here we have our 10 frame with our number bonds. I'm just going to do this here quickly to show you to show you again here when adding 2 single digits, learners can make each number on a separate 10 frame before moving part of the number to make the 10 and then on one of the 10 frames, and this supports learners to see how they have partitioned one of the numbers to make 10. So you see how they're doing 8 plus 7. How are they doing 8 plus 7? Okay. See that? How they're doing 14 minus 6. 14 minus 6. Taking it this side and working it out this side here. How they doing 7 plus 6 plus 3. 7 plus 6 plus 3. Fill in the 10 first. Your color codes help you here. Okay? Your color codes are helping you here. So, like I said yesterday, I'm going to, when I recover my other PowerPoint, I'm going to be making little PowerPoints for your subject advisors during our subject committee meeting in early February, so that they can then give you these little PowerPoints so that you have this teaching bits and you have more examples, and you will have this, and they will support you in this way by giving you this little PowerPoint, okay, so that you can see how it works. They will either do it with you, and they can also give you the PowerPoint. I'll put it into small bits of about 12 slides per PowerPoint, okay? Some of us are using the beads. That also supports the tens, filling the 10, okay? So, yeah, I'm just going to show you the addition and the subtraction via the number frame, and later we take them to the number line. So this is the number track here, the number track rather, where we have 5 plus 3, and we did 10 minus 4 on this number track, and here we're doing the 15 plus 7. 8 plus 7. 8 plus 7 giving you 15, and we can also do below here, we can also ask them to show us now how do you do 15 minus 7, and we see what they can do, and whether they do the 15 minus 7 on top of the number line or at the bottom of the number line, it doesn't matter. Again, the skill is important as long as they can see that they're taking away from 15. Either way is a winning way, okay? And here we do breaking down one number to fill the 10, or to make it easy to count more on the number line, right? We first did the number track, and now we're doing the number line. That's the difference there. And as your learners graduate to bigger numbers, you'll see that they will be using a blank number line, and they will then do this later. This will come later on in the year, but more of this later, right? What's important is for us to understand whether learners can use the groups of 10, whether they can use the bundles, or whether they can use the Dean's blocks, the place value blocks, and they can do the addition and the necessary subtraction by using these concrete apparatus. That's very, very important. I'm just going to show you this via the Dean's blocks so you can also see how it's done and how it builds, and it lends itself to later on, gradually to later on to the column way of doing things. Okay? So we take it this way, and we just show quickly. Okay? So that's just to show you how they work with the Dean's blocks. So more of addition, not going to go there. I'm going to just go here quickly. We showed you that bit of the number skill with adding 1-digit numbers within 10. We've done that. We've worked on that. Worked on that. Again, very, very important. I can't stress enough. You're not going to make headway. You're not going to move with your learners if they don't know their bonds up to 10. And if they cannot do that, fill in the 10 with regards to 7 plus, 8 plus, 9 plus, 5 plus, etc. Very, very important. Then we can move on to 2-digit numbers to the 20. How do we get there? When do we get there? Okay. Linking it, like I said, to the counting chart for them to show you the numbers. Very, very important. 10s and 1s, 10s and 1s. I can't stress this enough, teachers. You need to use your Dean's blocks. If you don't have Dean's blocks, use your counters, use your 10 frames. Let your learners draw and show you how they do it. Engage them. Show the concrete, the pictorial you want to see, and then the abstract. There's our place value cards. Place value cards stay with the 10s and the 1s for now. This will actually be shown tomorrow for the grade 3s. Okay? Like I say, I have another PowerPoint here where I actually included a bit of grade 3 work as well. So adding 3 digits, we're doing quickly. Have a look at that. Subtraction. working backwards on the number line, taking to the number line. Eventually, they wean them from the number line, but it's good for them because they're building that mental number line. So do they have this in their minds? Do they have the 14 minus 6 is equal to 8? Can they do it on the number line as well? Just go in that way quickly so you can see. I need to get to another fill in this is another picture that you can work with for the whole week in the classroom. Number sums. A farmer is filling baskets of apples. The farmer has 24 apples and 4 baskets. If she divides them equally, how many apples will the farmer put in each basket? Right? Doing this way, I'm just going to romp through this quickly because we worked on this at the start with a workbook with your the girls, etc. This will be for grade 3. This is just to show you also how you can link the counting, how brilliant it is with your money, with your Dean's blocks as well. Okay? Okay. The question is, are you using flashcards? Do you have your set of flashcards in your classroom for your mental maths and just to question your learners in the morning when you're busy with your counting and your mental maths? Okay? How do we get this going? And this will also tell you quick whether they have learned fill in the 10 or not yet. Right? More examples of your flashcards that you can have. Putting them out on the board, asking them which are the missing flashcards. Let them come and get the missing flashcards and put it in so they can see the patterns. These are all patterns, teachers. These are all patterns. This is what maths is all about. It's all about patterns. Can the learner see the patterns? Can you see the patterns? Okay? Collect the flashcards that have the same answer. Look at how the numbers are lined up. What do you notice? What are we noticing here? Can we see in this row we're doing 11 minus all the way. We're doing 12 minus all the way. We're doing 13 subtract all the way. We're doing 14 subtract all the way. Going down, we're increasing the numbers. We're increasing the numbers all the time, but we're starting with 11 all the time. Can we see the pattern? Do we have these flashcards? That's my ask to you. Do we have these flashcards? How well do I know what sabotage is? How well can my learners sabotage? How well can they have this picture? Do they have this picture in their minds? Everything at the bottom here relates to, can you see can you do that quick recognition of the number? So what kinds of sabotaging do we get? We get perceptual sabotaging, which is the quick recognition. That there are 5 dots on the dice. As you can see the dice there, that shows you that. You get the conceptual. That shows you the domino has 6 dots instantly, and you recognize it as 2 groups of 3. The same with the eggs I showed you from the onset. And then we have the advanced conceptual sabotaging, where we have the 10 frame, which you can see clearly is your 5 and your 2 will gives you 7. Okay? So I'm asking in the mental maths in the mornings, can we do something like this? Sabotaging that supports mental maths and build number sense. Sabotaging helps learners to gain deep understanding of quantity. Sabotaging develops the ability to recognize quick comprehension of quantities. Understanding and nurturing sabotaging skills lay strong foundations for mathematical ability later. So we can use card game. We can use card games. Cards can be shuffled and randomly arranged. What cards are we talking about here? Have a look at the top. Have a look at that 2 cards already that's showing you. Giving you an idea. So here we have each card. You can hold up each card for approximately 3 seconds, and then you can ask learners, what did you see? What did you see? The same way you use the Lego blocks. The other teachers are using Lego blocks when they put them in different colors and they show the learners quick. Give them 3 seconds to look at it. Put it behind their back. Now you do now you place your colors exactly the way I've placed the colors on the Lego blocks. This is for the recognition for sabotaging. Can you see how from the concrete we go to the pictorial? Can you see the links? If you stack your Lego bricks a different way, your 6 bricks a different way, that's just to do with 6. Show learners. Hold it behind your back. Let them stack their own the same way. See how many of them can actually remember that. Visual memory. Okay? And that's what we're doing here with your sabotaging cards here for your mental maths in the morning to strengthen that concept, to strengthen that skill. Make an immediate accurate recognition of a number of dots in the group without any actual counting. Okay, what do they learn? They learn to comprehend quantities of objects as a skill. It can help them with mental calculations, estimation, and problem solving. That's what we ultimately aim for. That's what we ultimately want to do. So here's a quick recognition of the bonds of 10. Do they have this mental picture? Do they have a mental picture of there's more sabotaging cards there? How do they develop this through sabotaging? Can speed up mental calculation in the column addition, and understanding numbers composition, for example, noting that 8 and 6 and 2 is what? Can they do the bonds? Can they regroup? There's 6 and 2 is 8. Do they know 4 and 5 is 9? You know, the ability to visualize quantities to support estimation skills that are crucial for checking the reasonableness of the formal calculations. Board games with dice, absolutely brilliant for the classroom as well, for when learners have completed work. It teaches so much skills. Okay, quick recognition of the 10. There we have. By understanding and nurturing sabotaging skills, teachers can lay a strong foundation for learners' mathematical journey throughout. Look at this. Can we sabotage here? Can we count the columns? Can we do the mental calculations? Can we do in the top one? Just at one picture. How well can you, as a group of grade 2 teachers at your school, take this picture, the top picture, and work out problems for this picture for the whole week? That's a neat challenge for you. Work out word problems for the whole week, just using this picture. Okay, here we see 3 groups of 10, 2, 4, 6, 8, 10. That gives us 30, and work on that. And then again, you can work at a problem for this year, but if you go to your DBE workbook, page 70, you'll see. You'll get an idea. But I want you to try and keep that open mind and take that one example. There's a beautiful picture that I made an example of, and I promise you I'm giving your subject advisors the PowerPoint. With the books stacked. They're stacked in 10, and there's about 4 scattered on the table, or 6 scattered on the table. So it's 4 and 6. 10 and 6 will give you 16. So you take that sum, and you take that picture, and you craft. You literally script 5 word problems for the whole week just with that one picture. I've done it. I will share it with you so that you can see how your learners can get the practice, because like I said, repetition is the mother of all learning, and incessant repetition and practice is key to embedding the knowledge and for learners to know the bonds and the addition and the subtraction. And just to, once they know their bonds, they're able to do their problem solving. They'll be able to do their word sums. So what do we do with regards to assessment? We know it's 1 assessment task per term. I've mentioned the fact about steer away from that 100-mark question paper. It's criminal, teachers. It's absolutely criminal. What do we do with regards to formative assessment? What tools do we use? We can go to this little booklet on the website. We can get some items as an example to use, or some exemplars. We can go to our CAPS document, to section 4 in the CAPS document. There are examples of formal assessment tasks. They give you brilliant skills and knowledge, exit skills and knowledge for each term. There's up to three assessment tasks for grade 2 per term that they show you there. Because remember in the onset we had to do 3 or 2 per term. It's still there for you. That critical skills and knowledge is what you must gauge to see whether your learners can do that at the end of the term. That's important. Very, very important. We know we use this weighting. So as a teacher, what principles do I adhere to? What do I need to know? I need to know teacher agency. I need to know what my belief is, what difference I can make here with my learners, and how can I extend my learners beyond the classroom. That is key. What am I prepared to invest in my teaching? How well am I going to capacitate myself? Because if I don't have the mathematics knowledge, and I don't have the pedagogic, the methodology, how to teach maths, how can I impart the knowledge to my learners? How good is my knowledge? My knowledge must be tenfold compared to my learners. I must know maths at least up to grade 10 in order to teach grade 2 mathematics. Aptly in the classroom, optimally in the classroom, to do that deep teaching. Because I must know the trajectory, I must know the learning pathway, I must know where I'm taking my learners to. What's the grade 3? What must happen in grade 4? I must be aware of this, I must see the big picture. Time, I must make the time to do the deep teaching. Okay? Make the time to do the deep teaching. That's very, very important. Deep and meaningful teaching. I must collaborate. My colleagues know more than me. We must share ideas. We must work together. Teaching approach, we know we use the concrete, pictorial, and abstract. We know that teaching a concept, we must make links. I've spoken about making links all the time. We know that we must afford various practice opportunities for learners. Repetition is key in order for them to master the particular skill. Okay, assessment is absolutely key. I spoke about formative assessment from the onset. Formative assessment is absolutely key, right? And what resources I use, I can't impress enough. Go to the DB workbook, go and unpack it, go and work down from that book. Go and see how you can make the links. First and foremost, your policy document, your clarification notes are key. Then you go to your DB workbook to see for activities, for ideas. And like one page, if you can take one page and show me, yeah, Bonnie, I've taken one page and I can do 5 activities for the whole week with this one page. You're on a winning stream, I'm telling you. Okay? That's all your apparatus, that's all your books for the whole phase. Every grade has got those learner workbooks. Nothing has changed with regards to the ATP. Nothing has changed. Just remember, you teach and you manage your classroom for pure maths for 7 hours for the week, more or less 1 hour, 24 minutes per day. Nothing has changed. In conclusion, I want to impress upon the fact that we teach well for effective learning, for deep. We do the deep teaching for learning, for optimal learning. We want our learners to be eloquent in maths, to be able to have that visual picture, know the bonds, know that this repeated addition leads to multiplication. Know that I'm counting in twos, I'm singing the song. But here it relates to this on the counting chart, it relates to repeated addition, it relates to the multiplication tables. Are you seeing the links? Even if you pack at their pairs of shoes, they undress them, they take off their shoes and they put their shoes together and they count 2, 4, 6. They count the pairs of shoes. Can you make the connections or just put them together so they can see? Counting the body parts. They must see this. Teachers do it practically first. Then you go to the abstract, and then you go to the semi-concrete, the pictorial, and then you go to the abstract. But your mind must be clear, and you must know that your learners can do the concrete. Okay? So with that said, I have a little video here. I hope my volume is on. That I want to say, I'm sorry for keeping you a bit late. I'm sorry for starting this meeting late. But I'm so passionate about grade 2 because I know that grade 2 is so sorely neglected. But grade 2 was actually my best year that I taught. My best class to teach, grade 2. Because you're getting learners from grade 1, they know something they can read, you can move with them. You can take them to another level, you can extend their capacity. So give them the best that you have, teachers. Work collaboratively, share ideas. I promise you I'm going to share the PowerPoints with you. You're going to see it better when I break it down in the PowerPoints as well. So all I'm asking for you is to give our learners nothing but the best, to instill that love and for mathematics, so that learners feel that they want to take maths right up to matric. Right up to matric, that's the aim. Okay? That is the aim. And it's a life skill. They must go to the shop and know exactly what change they're getting if they're spending money and paying the shopkeeper. They must know these things. That's where the maths come in. So I'm going to leave you with this.
I was at the airport when a taxi driver approached me. The first thing I noticed in the cab was a phrase I soon read: duck or eagle, you decide. The second thing I noticed was a clean, shiny cab. The driver well-dressed, white shirt and well-pressed pants with a tie. The taxi driver got out, opened the door for me and said, "I am John, your chauffeur. While I'm putting your luggage away, I'd like you to read on this card what my mission is." On the card was written, John's mission: to get my clients to their destination quickly, safely and economically, while providing a friendly environment. I was impressed. The interior of the cab was equally clean. John asked me, "Would you like some coffee?" Joking with him, I said, "No, I'd rather have a juice." He immediately replied, "No problem. I have a thermos with regular juice and also diet juice as well as water." He also told me, "If you wish to read, I have today's newspaper and also some magazines." As the race began, John told me, "These are the radio stations I have and this is the repertoire they play." As if that wasn't enough, João even asked me if the temperature of the air conditioning was good. Then he told me what was the best route to my destination, and if I wanted to talk to him, or if he preferred that I not be interrupted. I asked, "Do you always serve your customers like this?" "No," he replied, "not always, only in the last 2 years. My first few years as a taxi driver, I spent most of my time complaining, just like the other taxi drivers. One day I listened to a doctor who was a specialist in personal development. He wrote a book called Who You Are Makes the Difference. He said, "If you get up in the morning expecting to have a lousy day, you certainly will. Don't be a duck, be an eagle. Ducks just make noise and complain. Eagles soar above the pack." I was all the time making noise and complaining, so I decided to change my attitudes and be an eagle. I looked at the other cabs and drivers, the dirty cabs, the unfriendly drivers, and the dissatisfied customers. I decided to make some changes. Since my customers responded well, I made a few more changes. In my first year as an eagle, I doubled my turnover. This year, I have already quadrupled it. You are lucky you took my cab today. I am no longer at the cab stand. My customers book through my cell phone or send me a message. If I can't pick up, I get a trusted Eagle taxi driver friend to do the job. John was different. He offered a limousine service in a regular cab. John, the taxi driver, decided to stop making noise and complaining like ducks do, and started flying over the group like eagles do. It doesn't matter whether you work in an office, with maintenance, a teacher, a civil servant, a politician, an executive, an employee, a freelancer, or a taxi driver. How do you behave? Are you dedicated to making noise and complaining? Are you elevating yourself above the others? Remember, the decision is yours. That key only opens from the inside, and you have less and less time to change. 2025 will be nothing new if we don't have new attitudes. May we be better fathers, better husbands, better wives, better mothers, better children, better friends, better colleagues. May we not repeat the mistakes of the past. May we pray more, praise more, thank more. May God Almighty give us the wisdom we need to be eagles, so that we can fly high and live in a better world of peace. Let's be eagles in 2025.
Let's fly high, teachers. Let's do our best. I want you to just go to the and by that I just mean thorough planning, connecting with learners, teaching optimally, observing your teaching, observing the learning, and giving the learners credit where credit is due. And I want to also take you to the fact that we just had the Daily Maverick had an article written by Professor Michael Le Cordier from Stellenbosch University. The prof says, why our children can't do maths, it's a matter of, and he says there, I want you to go and read that article and think about it. He says, why our children can't do maths, it is a matter of teachers who cannot or will not teach. And he writes that article. Okay? So that is why we're saying, I always say, children can learn. Children want to learn. Our children can do the maths. I want us as teachers to top up our knowledge. Okay? To make this year our year, to improve our knowledge so that we can deliver optimally in the classroom. Nothing but the best. You can do it, teachers. Work collaboratively. Ask your subject advisors for support if you need support. And like I said, I'm going to do that little PowerPoints for you so that you can lean on that as well. This term still. Okay, grade 2, you'll get your PowerPoints first. In the first, don't worry. Like I said, it's actually the very critical year, a lovely grade to teach. Just give it your all. Just remember, you can only teach well if you yourself has internalized the knowledge, because then you have the ability to put it across, to transfer the knowledge to the learners. So with that said, I'm going to leave you. Thank you for listening, and I hope that at least something resonated, and I will be delivering on the PowerPoints. So thanks for today. Thank you. And thanks to the North District for opening up the platform for the whole country to be part of this endeavor. Okay? So maybe we need to do a bit more for grade 2 early in the new term or the end of the term. They can write it on the register where they can fill in the part. So in the chat, what support they need. We need to give them some more support. The grade 2s. Okay? Because they're sitting with children from that can learn. Tell us, teachers, what you need support in. And the endeavor will be to do another webinar with grade 2 teachers. Okay? Thank you.
Anita,
Thanks.
sorry,
Yes.
there's just one question before we go off the chat.
Yes.
One of the teachers said that she thought she saw you do column or vertical method or something like that, and she wants to know what is allowed. Is it column or vertical method?
She can wait for the PowerPoints, okay? Because it's not column or vertical method, it's leading up to. There was a whole process leading up to that.
Yes, I
Not
thought
going
maybe
to start,
because you went
okay?
a little fast through it
Yes.
that they didn't understand it
No.
so well. But
No.
all the questions are posted onto a Google Sheet and they will be answered, and that will be shared with schools.
Yes.
So please allow me to say thank you so much for this afternoon, Benita. And then one other request is that the people ask that you share the article that you keep talking about, that you share that with them as well. Ms. Gutham's details are available on the slide right now. You will receive the recording of the session for today. And please don't forget to sign the register before you leave the session today. Bonita, thank you so much once again for sharing your vast knowledge with us, especially with regards to grade 2. And I'm sure that we've all learned so much this afternoon. I have learned something new again. And we are truly appreciative of everything that you are doing to raise the educational levels of our grade 2 teachers. Thank you.
Okay. Thank you, Jen. Thank you, North District. Thank you, Western Cape, for your support there. Thanks, Carmelita. Please just look at your workbooks, go to your CAPS document and look at what's been done there with regards to addition and subtraction. Okay? The eye just probably saw something and you want to latch onto it. I did it showed you with Dean's blocks, I showed you with bottle tops, I showed you with a 10 frame. Everything, okay? So take heed of that. Some of you are busy with programs. I don't know if I said it earlier. Some of you are busy with programs. You stick with your programs. But you as a good teacher will know that you will check up in the CAPS document to see where there's a lining and whatever. And you are probably doing a program, a special program in your province that you probably got exemption from using the DBE workbook, so you got exemption from using the CAPS documents. I don't know. I don't know this. All I'm doing here is to try to help you to keep an open mind so you can see the vastness of the maths that you need to teach our learners and how you need to make the connections for them, how you need to link up. Nothing is taught in isolation, okay? I can do the same numbers and work with the same bottle tops and do your patterns, algebra, patterns, functions, and algebra. I can do your space and shape. I can do measurement, and I can do data handling just with bottle tops. How do I do that? Think about it. Okay, so we tend to see what we want to see and we tend to only teach what we're comfortable with teaching. There are no easy ways out. There's no tricks in mathematics. There's absolutely no tricks in mathematics. Remember what I said? Practice and incessant repetition is going to embed that knowledge. varied and multiple opportunity. And your deep teaching. And how do you teach deeply? Think about that. That very same example I started off with in the concrete, pictorial, abstract. Make sure that they know. Use it in give different ideas, use different apparatus. Okay? Show links. Very, very important. Show links. Remember, this math skill must be a lifelong skill for your learners. So if you're teaching them to know 10 well in grade 2, it must go with them through life. They must be able to preach that 10 wherever they get. Because if they can preach 10, they can preach 20, they can preach 30, 40, 50, they can preach 100. Think about that. So how well and how solid have you embedded that concept? That's what we want, teachers. Okay, I can go on and on and on. Forgive me. Safe home for those driving, and I'm going to say good afternoon.